Hi, welcome to QuBites, your bite-sized pieces of quantum computing. My name is Rene from Valorem Reply, and today we're going to talk about enterprise quantum computing and quantum machine learning again. And for this, I'm very honored to have a special expert guest today, Santanu Ganguly. Hi, Santanu, and welcome to the show. How are you today?
Hi, Rene. Thank you very much for having me at the show. I'm pretty good. I hope you are too during these dynamic times. Yeah, thank you for having me here.
Awesome. So before we start with the questions, can you tell us a little bit about yourself and your background as it relates to quantum computing, computer science, and all the field here?
Sure. I was always a student of physics, and in fact, I was doing my PhD in UK and in physics, and then I got an opportunity to work in Switzerland in network engineering, sort of domain. So I thought, hey, it'll be nice to go and live in Zurich for a while. So I left my PhD and went to work in Switzerland, and I enjoyed it very much. But fundamentally, my background is in physics and math. I've got a postgrads in both subjects, and then of course I spent quite a few years in computer science and related subject matters as well. So that's my basic background. Yeah, that's who I am. Thank you.
Aw- Awesome. And so you're also working at Cisco, right? And which is a large enterprise company, very much famous for networking and many other things. But what are some of the topics at Cisco when it comes to quantum computing, and what role is quantum computing actually playing in these kind of enterprise systems at the moment?
That's a very good question. So to answer the first part of your question, is absolutely right. Cisco is basically in 70% enterprises across the world, and we have got a very healthy customer base there. We have, and Cisco has traditionally led networking, servers, computer systems, software, everything in the industry. And we are also aware that quantum computing and security related to that is something that is upcoming, something that is happening today as per NIST, as per NCSC.
Hmm.
And we are actually very consciously in there working with the standards divisions to meet those criteria. So that's where we are. We are telling our we are telling the industry that we have our foot in there. We are working with
Yeah.
post quantum crypto currently. So that's our model right now. We are also looking at other branches of quantum computing, not just quantum computing, also communication. So,
Hmm.
for example, today there are different types of quantum computers. You have superconducting quantum computers from IBM or Google. You have annealing based computers, quantum computers from D-Wave. You have photonic quantum computers from Xanadu. But none of these computers, even though they are of the same hardware, has ever communicated between each other. And this is where Cisco comes in because we are a communication company. So that is our major focus is quantum internet. Now a lot of people will laugh at us or me if I say quantum internet, and it is true, it's quite a few years away. But if we sit back and tell people it's quite a few years away and we won't work on it, that's not gonna get us to where we wish to go. So
Yeah.
our policy is to follow Abraham Lincoln saying that you know, you need to build your future. To ensure your future, you need to build it yourself. So that's where we are. Thank you.
That that very much is like, I love this statement you were just saying, right? It's like you can always say, oh yeah, that's too far away. It's like, oh, that doesn't work. Like, but if you never move, if you if there's no early mover, like no one will move, right?
Exactly.
So someone got to take, and it takes brave people like you and the team, right, to actually do that and work on a mission. And also, myself, of course, I'm also just working on emerging technologies, and some of those might not turn out to be a huge business, but others will, and that's you got to take that, and you got to work on it, especially like you were saying, like with Cisco being a large network company. And maybe another question regarding to that, the whole QKD, like the quantum key distribution, and the amazing progress I just saw, the other day that in Japan they made a new record in June this year, I think, with a 600-kilometer long quantum key distribution channel, which is quite impressive. But I guess that's also something you guys are looking at, right?
Very much so. So currently, Cisco's vision, and we actually, as we speak, we have a solution, as in our software, implemented for post quantum cryptography. When I say post quantum cryptography, I mean using classical encryption, not quantum, but classical encryption that is
Yep.
theoretically supposed to be quantum proof. So
Yep.
why are you doing this? Because again, as I said, we are following the standardization. But now that we have a PQC solution, we
Mhm.
are also working with universities and research institutes to look at options of taking it to the next step. So if and when the standards body decides that okay, today is the day that QKD should go into networks, we will be
Right.
ready if that day ever happens. And at the same time, QKD is also part of that communication stack that I spoke about.
Hmm.
When
Yep.
when you have two quantum computers communicating between each other, there are stacks of security, there are stacks of communication, there are stacks of resource management, various stacks. And that's something we need to think about, not just transforming one qubit from one point to another, and then, because that does not serve a large scale purpose. So
Yep.
yes, you're very correct. We're definitely looking at that.
Yeah. So that the scalability is of course the challenge, but this is important to actually move it into production out of the research labs, and that's one of the pieces you guys are working on. Awesome. Is there any other thing you would say where you're already seeing impactful applied quantum computing solutions, like quantum inspired computing, or anything else where you would love to share an example about?
Sure. I think major impact right now as we speak. One of the major impacts is in chemistry and molecular modeling, and that's not just quantum computing. There's also an aspect of quantum machine learning there. So you asked for
Mm,
an example, and I think one of the ready examples in my head right now is the research team at Penn State University in US, who
yep.
are actually looking at modeling of COVID vaccine using quantum computing.
Really?
And this is a research group being led by Dr. Swarup Ghosh, and they actually started working on it, I think, early last year. So that's one example of it. But there are various other examples in drugs industry, in protein folding, and that's just in chemistry and molecular modeling. On the other hand, there is a very large push from the financial industry
Hmm.
towards quantum algorithms and machine learnings as well. So you may be aware that Goldman Sachs has built up a quantum computing research team. JP Morgan is doing the same thing. And
Right.
all these guys are doing it because they see an advantage there that they have missed, or probably they think they cannot get in classical computing. So,
Right. 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 It's these. I mean, if we think about portfolio, risk analysis and all of these problems, these are these super like NP complex problems like that are just incredibly hard because they're exponential. And with classical computer, it doesn't work that well. But with quantum computers, you basically add another qubit and you get another exponent at it, so you can solve these exponential problem in linear polynomial time. Depends really on the problem, but um, yeah, it totally makes sense. Actually, in fact, at a quantum conference earlier this year, I don't remember which one, but there was a speaker basically also talking about quantum finance, and he basically said like financial institutes need to get on the wagon now, because otherwise, if they miss the opportunity, they will be gone out of business in like 5 to 10 years, right? Because they cannot. Their competition will be so strong, basically, with the all the financial institute that invested already in these kind of technologies. But speaking about quantum machine learning, I also know that you wrote a book about applied quantum machine learning, which sounds actually super exciting. So, can you tell us a little bit more about your book? And of course, first of all, the title and where folks can get it, but also what you cover in there. Would love to learn a little bit about it.
sure. The title of the book is Quantum Machine Learning and Applied Approach. And I went for the applied approach because prior to starting to write the book, which I did during the lockdowns last year, there were two, I think, mainstream major works on quantum computing. One was the first ever one was by late great Dr. Peter Vitek. He wrote a book on quantum machine learning back
Mhm.
in 2011, I think. And then, of course, there is the seminal volume by Dr. Maria Schultz and Petruccione, supervised learnings with quantum computers that
Mhm.
came out in 2018, and they were great read, especially Maria Schultz's book. I really enjoyed it. I have it right there, and the the thing is, I enjoyed those books, but what I realized after I went through them and after I started to dabble in hands-on quantum computing itself is, like I said before, there are so many various quantum platforms. There, IBM has one, Google has one,
Yeah.
Xanadu has one, D-Wave has one, Rigetti has one, and several others. Now,
Yeah.
you have this whole bunch of quantum algorithms, the theory of which are all explained in these books very nicely. How do you apply those theories and those algorithms to these diverse platforms? Number one. Number two, do all those algorithms give you similar advantage on every different platform? So
Mm.
these are things that sort of triggered my interest in writing a book with an applied approach. So my approach, or what I tried to do, is introduce the theory and then introduce the coding bit, be that Google, be that IBM, be that Rigetti or DOF Systems. So I'm very grateful to DOF Systems. They actually reviewed my two chapters on DOF Systems to go through. Where you mentioned NP hard
Nice.
problems, I actually did a code, a sample code on traveling salesman problem, and
Nice.
Rigetti's max cut problem, which are all NP hard. So that was my thinking, that look, there are lots of people like me around who have all these four or five different platforms in front of them, and they have all
Yeah.
this theory which they understand, but perhaps it'd be good to try and bridge that gap where they understand and where they apply. So
That's
that's
awesome.
that's where it came from.
That's amazing, and exactly, I think these are really the missing pieces here to, help people to actually get into quantum, because you have a lot of academic and scientific like papers and books and whatnot, but like this applied approach that you cover in your book, this is really missing in the market. So, folks, get a copy. I will also order one, of course. It's definitely worth investing, because this is definitely the future. And maybe the last question for you regarding QML and in general, what I was just talking recently with Johannes Oberreuter with another episodes of QuBites, which you should all check out, about QML in general and image classification, QML image classification. He was telling me like the early results they have, even with small quantum computers. Basically, you inject a layer in your neural network with for quantum computer and a later stage, right, when the features were basically extracted, and they were seeing like better accuracy already, like even with the small quantum computers. But it's like, why is that the case?
I'll try to explain my point of view on that. So image processing, as you correctly point out, is a very very important part, not just for academic purpose, but also for security. And the reason for that is, if and when we are ready to have quantum sensors out there, some of which are being produced right now, what
Right.
you'll get 3D data in three
Mm-hmm.
dimension, which is essentially quantum data. Once you get quantum data, so okay, I'll first try to answer your question and then I'll go to what I'm saying. So your question was existing data and why some results are better. The reason for that is, again, when you take a classical image and you piece it up, you chop it up in little pieces, and you transfer it into a quantum image processing algorithm. There are several. FAQR comes to mind. NEQR comes to mind. FRQI comes to mind. Sorry, I misspoke before. What it does is it gives you that probabilistic application of quantum mechanics to
Yeah.
optimize or deteriorate your image further, or optimize it further or deteriorate it further. I'm not saying every run of those processing or machine learning runs will give you an amazing optimized image. It may not, but some runs will give you the optimized better version. The reason is you take, when you transfer, when you process a classical image into a quantum machine learning process, you take a classical image, and what we typically do is we do feature mapping. So
Hmm.
from a classical XY 2D image, we map it into a Hilbert space where it's more than two dimensions.
Yep.
And is those multiple dimensions that gives it the added power, because you get so many various different probabilities to apply. And this same thing will apply once we get what I was talking about, the 3D image or quantum image. And then we should be able to see around the corner. So if you have a building, we should theoretically be able to see what's happening behind the building once we have that kind of data and quantum processing.
That actually makes a lot of sense. Is you can represent your data better and closer to the nature, if you will. Um, so
That's true.
yeah, no, that's awesome. Well, unfortunately, we're already at the end
Right.
of the show. I think we could talk for many more hours, but I thank you so much, Santanu, for joining us today and sharing your insights. That is highly appreciated.
Thank you for having me, and thank you very much for your kind words, and thank you for your attention.
Yeah. All right, folks. Thanks everyone for joining us for another episode of QBites, your bite-sized pieces of quantum computing. Watch our blog, follow our social media channels to hear all about the next episodes and when we release them. So far, take care and see you soon. Bye bye.